4.1 problem number 6 says, find the value of the right-hand sums, the limit as n approaches infinity of the sum of I equals 1 to n of the product of pi divided by 6n times tangent of I pi divided by 24n is equal to the area below the function f of x on an interval a to b. Our goal is to find the function f, a, and b, and do not evaluate the limit. So we first have to observe that this is the form of defining what it means to be an integral, which is the limit as n approaches infinity of the sum of I equals 1 to n, or f of x sub I times delta x. Well, we just need to find delta x and x sub I. Well, it appears that delta x is pi over 6n because that's not dependent on I. And so we know that delta x equals pi over 6n. And so visually that means we have points where our x sub 0 is equal to a, or our beginning point, our capital A in this case, and our x sub n is equal to b. If you're wondering why this is n in this case, well, we know that the interval is broken up into n sub intervals. So what that means is all of these pieces adding up within this segment means that there's n of these. Well, what is the length of each segment? It's our delta x. We should find what these integers are. Well, suppose there's an ith number within this interval. Well, that would mean that x sub I is equal to I pi divided by 6n, because we have each of these intervals is worth pi over 6n. This is a pi over 6n. And when you add all of these up, the x sub nth interval is our b, but we know that there's n of these pi divided by 6n's. Well, in that case, we can use algebra, and pi over 6 would be our x sub n, or our upper limit, b. Well, in order to find x sub 0, we need to use this rule that there's some number in here, some x sub I, such that it's equal to I pi divided by 6n. Well, this would imply that x sub 0 equals 0 pi divided by 6n, or just 0. So our a is 0, and our b is pi divided by 6. But what would be our function of integration? We need a f of x sub I, and what we have is tangent of I pi divided by 24n. Well, let's look at this x sub I down here. We know that x sub I is I times pi divided by 6n. Well, we can use algebra to rewrite the function tangent as I pi divided by 6n And when I divide 24 by 6, I would get just a 1 over 4. Well, I would just get a 4, but in this case, the 6 was in the denominator, so the 4 would become the reciprocal of 4, which is 1/4. And now I can just substitute my x sub I. So our function f is x sub I divided by 4. Well, we have our a, we have our b, and we have our function. And so now we can say that this is the same as the integral from 0 to pi divided by 6 of tangent x divided by 4 dx.